Hello, everyone.
Oh,
I believe most of you you have successfully uploaded Lab 1, and today you are going to finish all what is required for homework 1. And we have only one exercise to do, but it is long one. This exercise is about adders. Of course, we are adding in binary. We are adding two binary numbers, A and B, and we are supposing that we have only one digit. One digit for A and one digit for B. And this is the truth table of the adder. We have A and B, those will be my input. What about the output? This is the summation and a carry. A carry if the number exceeds the limit of my summation, I will have a carry. Here I'm saying if A and B are both 0, the summation is 0, of course, no carry. I'm adding 1 to 0, I have a summation 1 and no carry. 0, 1, I will have summation 1, no carry. Last, if I have 1 plus 1, that should be in decimal 2. And 2 is denoted in binary as 0, 1. So my summation is 0, and I am moving to a higher bit that is my carry. That is how the carry is. If I look at this one, it says this is a summation AB, and I will have sum and C out. How to build it? To build it, if I look at the truth table for summation, the summation is high whenever A is not the same as B. That is when B is 1, A is 0. Or B is 0, A is 1. This is exactly an exclusive OR gate. So the summation, I can model it by exclusive OR. What about the C, the carry? The carry is always 0 unless I have A and B are equal. And that is the AND gate. AND means A and B must both be high to get a high. So this is an AND gate. So if I have this circuit, I will get an adder. But this is a half adder, not full adder. Why it is not full adder? Because full adder would need to receive a carry also. So it will be 3 input. Yes, I will have a summation and carry out. And I need also a carry in. So the full adder differs from this one. This has 2 inputs, A and B. Here I have 3 inputs, A, B, and carry in. And let's see what is happening. First row, ABC 0, 0, 0. I get summation 0, carry 1. Second row, I have 1 only, so I get 1 on the summation. Second one, 1 only. Oh, this is number 4, this one. I have 1 plus 1, that is 2. So I have summation 0 and carry 1. I have another one similar to it here, 1, 0, 1. I have two ones. So I have 0, 1. This is the same also. And this is the last one. 1 plus 1 plus 1. This one should give me a 3. And 3 is written in binary, 2 to the power 0 and 2 to the power 1. So I have here 1, 1. So this is my output. How to implement this? I can use two half adders. The first half adder will take AB. The output of the first half adder will go to the second half adder with the carry in. If I look at this one, what will be the summation? The summation will be, as we know, for a half adder, this input exclusive OR with this input, as we can see it here. A exclusive OR B, and we have here, this is C in, exclusive OR C in. And what will be the carry out? The carry out, as we have seen it before, it takes one input and carry out here, ORed together. I am ORing the two carries, carry out of the first stage and the carry out of the second stage. Now let's see this example. Hello, Brandon.
Hello.
I cannot hear you.
Oh, hello. Can you hear me?
Okay, yes, now I can hear you. We have seen this truth table. Do you have my slides?
Yeah, I can pull them up 1 second.
Okay, okay. Would you all get my slides and open it, because we're going to need them. Slides for lecture 1.
Okay.
Okay, you keep this slide and I want you to look at this one. If I have this input, A is 1, B is 0, and the carry in is 1, what will be the sum and the carry out?
The sum will be 1 and carry out will be 0.
1 and are you sure? I have A is 1, B is 0, and carry in 1.
So are we assuming that there's a carry-in block on this one? Because there's... Oh, okay. Yeah, I see. Yeah, you're right.
So what will it be? Sum will be what?
I had it inverse. Sum will be 0 and carry will be 1.
Okay, because here we have 2. 1, 0, 1, that is 2 in decimal. In decimal, that is in binary, it will be 0, 1. So the summation will be 0 and the carry will be 1. And for this one, as a full adder, if you see here, 1, 0, 1, as we said, summation will be 0 and carry will be 1. Taylor,
Yep.
would you please think about A? Eric? Hello, Eric?
Sir?
Yes, would you please consider B?
Yep.
Paul? Hello, Paul?
Hello.
C, please.
All right.
Thank you. A is ready?
Yeah. So it'd be input 1 0 0. C out would be 0. Sum would be 1.
Sum will be 1 and carry is 0. Thank you. B?
On B with a 1 1 0 input, your sum will be a 0 and your carry out will be a 1.
Thank you. C?
Sum will also be 0 and carry will be a 1.
Thank you. Doing great. Parallel adder. The adders we saw so far, just one bit A, one bit B, that's it. And the carry, of course. But what will happen if I have 4 bits? The 4-bit number added to another 4-bit number, I need 4 full adders to implement it. So I have A1, B1. And the first carry coming, maybe I have another stage, but I'm concerned about this stage now. So if I have a previous stage, I will have this carry coming from 0, stage 0. If I don't have stage 0, I will just connect it to ground 0. So I have A1, B1, and C0. It will have a summation 1 and a carry 1. The carry of this one will go to the next stage. The next stage will receive now A2, B2, and carry 1. Carry of the previous stage. And I will get summation 2, carry 2, and going to stage 3, going to stage 4. Hello, Price? Price? Are you available, Price? Louis? Luis?
Yes.
Yes, sir. How many inputs are there?
So 6. I mean 8.
8, 1, 2, 3, 4, 8. What about C0?
C0.
So it is 9.
Oh, 9.
Thank you. Kobe,
Yes.
how many outputs do we have?
4.
Cowan, please. Still counting?
5.
This is 1. Correct, Kobe? Hello, Kobe?
Hello, can you hear me?
Yes, how many outputs?
5.
Excellent. We have 4 digits, summation 1, 2, 3, 4, and a carry of the last one. Carry out of the last one. So I have 8 inputs, 4 for A, 4 for B, and carry from 0. So we have here 9 inputs my outputs will be summation 1, 2, 3, 4, because this is 4-bit number, plus a carry from the highest bit, that is stage 4. Daniel?
Hello.
Hello, hello, hello. Would you please tell me what will be summation 1? This one?
Oh, yeah, so A and B of the first stage, it's 1-1-0, so there would be a carry out, and then it would be 0-1-1.
0, just a moment, just on 0, 1 here.
Yeah.
Thank you, thank you. Joe,
Yeah,
stage 2, what will be the summation and carry?
the summation will be 0 and the carry out will be a 1.
Thank you.
Yep.
Trevor,
Yes, sir.
stage 3.
Yeah, so for stage 3, summation 3 will be 0, and the carry out or summation 4 will be 1.
Yeah, that's correct. So it is 0, 0, 1. Excellent, thank you. Now let's get to programming. The program is very easily. We can do it here. This is my circuit. What will be the inputs? X, Y, Cin. What will be the output? Outputs will be sum and Cout. The entity, full adder. This is my full adder. And the architecture will be what? Summation will be what? XY XORed. And this XY XORed, I will XOR them again with Cin. What is Cout? Cout, I have here an OR gate. ORing what? ORing the inputs X, Y, and this X or Y, and this is my Cin. So this is my Cout. This should achieve full adder. Would you please start working on it? Try it and make a waveform. And of course, you need 3 input and you will have 2 outputs. Please go ahead now. Thank you. I'll stop sharing. If anybody needs any help, he can share or she can share the screen and everybody will help.
Yeah. I was
Yep.
trying to
Will you
make it.
please verify the input and output?
Yeah, so when X is 0, Y is 0, Cn is 0, the outputs are 0. When Cn is 1, the sum is 1. Is that correct?
Yes.
Okay. Oh
Don't
yeah,
you have
and
the
then
table? Check the table.
yeah, let me look. Pulling up the table. Okay. Yeah, and then when B is high, sum is 1. When B and C in are 1, then C out should be 1 and sum should be 0. And then when all are high, C out and sum are high. But
Yes,
yeah,
correct.
there we go. I was trying to get it to count in binary.
This is binary.
This is so 0, 1. Oh yeah, 2, 3, 3, oh, 4. Okay, yep. I
Will you
guess when I
please
got
show me your program?
yeah.
The program.
Yeah, one moment.
Okay.
Yeah, the program had like crashed, like when I was trying to do the waveform. Oh, there we go. So I just was not 100% sure if I was able to bring back the program, but there's the program. Because if your program crashes, you can't bring up the waveform again, right? You have to build it again.
Yeah.
Okay.
Okay.
I had a problem with that code. When I put in behavior for the bottom, it would, I was getting an error on line 22. So I had to remove behavior.
Is it,
And then-
it's behavioral?
Yeah, it was spelled the same as the top one.
Huh.
Mine worked.
And then when I
Mine worked
removed it, did it?
Yeah, I have behavioral on both. It works fine. But I've had mine crash a few times. I just keep hitting Control S every time I do
Anything.
something before I compile or before I do the waveform. I just hit Control S. Yeah, anything. That way, if it does crash, your stuff's still there. You know what I mean?
Yeah, that makes sense.
Is there anyone else who wanna share his screen? Is there anyone who needs more time?
I could use a moment. I'm recompiling it with behavioral and I want to see if it works this time, but last time I had it on it didn't. So I would see if you guys can figure out.
Okay,
Just a sec, it's compiling again.
we'll give you a few more minutes, no problem.
Okay, it worked this time. Never mind. It's good to go. I'm good to go.
Hello?
Yes.
I'm sorry. As soon as I said, my program was gonna crash, my computer crashed. So, what is it we're doing? I just missed like the last 5 minutes.
Oh, what do you mean by computer crashed?
My whole
Dead?
PC froze up and I had to reboot it.
Okay. Are you done, Daniel? Daniel? Hello, Joe?
Yeah, I'm here.
Your program is running?
Are we still doing the counter? I mean, the adder? Are we still doing the adder?
Yes. Have you finished the full adder?
No, I did the half adder. Like I said, my computer just crashed. Are we doing the full adder now?
This is the full adder. The one we did is the full adder. We didn't do half adders.
Oh, yeah, I already did it. Yeah. Do you want me to bring it up?
Yes, please.
Okay. Sure. Does that look like it? Full adder?
Please make sure that you have in the future, because we are going to use this program again. You have full adder, all small letters. Okay.
Well, that's what I did. Yeah. All small.
Okay.
Yep.
Thank you. Now show the waveform.
Okay. Open.
Why does it have to be all small letters?
Why does it have to be all small letters? I mean, I've had experiences before where like if it's labeled weird, it'll crash it for whatever the label is.
Yeah, maybe that's why I didn't compile the first time.
Let's see. Can you guys see? No. Okay. Let me change my screen here. Why is it not showing? New share. Why is it not showing? Crazy. Sorry, I don't know why it wasn't showing the waveform. It was showing it a minute ago. Let me recompile, do it again here.
You can close quotes and reopen it again.
Well, yeah, that's what I'm doing, because like I said, it was showing before when my computer crashed and I had to reboot, but now it's not. I'll just recompile it here. All right. Recompiled, done. And wait, this is not. Full editor, waveform, run simulation. Why is it not doing it? What the hell? Yeah, it's not showing the output now. When I run the functional simulation. What the heck? Yeah, every time I run the functional simulation now, it's not showing the output. So yeah, I guess I gotta fully close Cordis and reopen.
If need be, reboot the whole laptop.
Here, look at the file extension. It says counter.
Why is it doing that? Yeah. Counter, close. Open. I picked full adder. I picked full adder. Yeah, it's weird. It's showing counter at the top. But. Huh. I don't know. I guess I'll make a new waveform. Maybe
Yeah,
that
make a
didn't
new
s-
waveform. That's easier.
Maybe it didn't save correctly when my computer crashed. I don't know. Man. All right. I think I got it here.
Now it's working.
Looks good.
Would you please verify it step
Yeah,
by step?
so right here is 0, so everything's 0. Then we got a 1, so the sum out is a 1. And then we have a 1 and a 1, so that equals the carry out, which is going up to the next adder. And then same thing here. It's a 1, so that equals a carry out or a 2, right? And then it goes low. We still got 2, so 1, 1. Then everything goes low, so we got a 0, 0. And then we have a 1 on the Y, so 1. And it looks like it's working good. And then here we have a 1, a 1, and a 1, so we have a 1 and a carry. So yeah, looks like it's working good. Does it look good to you guys?
Thank you. Excellent. Okay. We'll continue. The coming part is very, very important. We built this full adder. It is 1 bit. What will happen if I need to build 8-bit, 16-bit adder? Will I write this 16 times? The answer is no. The modular design will help me do that. I will have modules and I am calling the same full adder according to the number of bits. I can call it 8 times, 7 times. This is using the component. Component, it is like a small subroutine. So my small subroutine will be the full adder you have just built and it is running. And I'm going to build 8-bit adder. So I'll be calling this component 8 times. Let's see how we can do that. This is my main program, library, entity, architecture. Here will be my component. The component declaration, it is just a copy of the entity you have just written, the full adder, because I'm going to call the full adder. So I put here the entity of the full adder right in here. Here in my main architecture, I will call this full adder 8 times as we are going to see. This is the structure of my program, what will be my output and input? My input A is 8-bit going to this 8 full adder. My other input is B, again 8 inputs going to those 8. In addition, I have carry in from the previous stage, if there is one. If there isn't, as our case, I will make it 0. But each full adder will have 3 inputs. So the first one, I need to feed it with 0. What will be my output? 8 summations, 0 to 7. Those are the 8. And the highest bit, I'll take its carry out. What are those red lines? I am taking the output, the carry out of the stage 0, feeding it as a carry into stage 1. Carry out of stage 1 going to carry in stage 2, and so on. Since these red wires are output of C out of this stage 3, and it is at the same time C in for stage 4, it should be a signal. I cannot say it is input or output. It is internal connection, and it can be input, it can be output. So this will be my signal. So I need those signal wires carry out of the lowest bit to the higher bit carry in. As you can see, I need 7 of those. This is the program you have just written, the full adder. The full adder, it is any one of those 8 boxes. And this is my new program that you will be writing. As you can see here, I have a subfolder called adder 8 and project adder 8. And this file, this is my main file. It is called adder 8. For this one, the entity, I have A, 7 to 0. B, again, 7 down to 0. C in, it is 1 bit. This one, this is C in. Summation, 7 to 0. And C out, this is my C out. Now I go to my architecture of adder 8. This is the one. According to this structure, I need to put here the component. What is the component? Component full adder, that is the one that I'm going to be using. I am saying here port. I copied I copied from here to here. Copy and paste, copy and paste. Copy and paste. This is my signal, the red wire. And here I am calling my full adder, calling the full adder 8 times. Let's see how we call it. We call the full adder, we call this process instantiation. I am calling what? FA0 full adder port map. Port map, what is port map? I am mapping my 1-bit full adder to my input and output, to my real input and output. My real input and output are called A and B and C in. But my full adder, those are called XY. So X will be A of 0. We have 8-bit. The first one will be A of 0. Y will be A of 0. C in will be C in. Please note here, C is capital, here C is small. X, Y, C in, C is capital. Sum on the full adder, it is connected to S of 0. C out will be C of 1. This is the first one in here. A0, B0, C in. The output is S0. And the carry is C out here. C out of 1. Now, I go to the second stage. The full adder side XY will take A1, B1. C in will be C1, sum will be S1. Now my C out of this stage will be C of 2 to go to the third stage. And so on until I end this program. To do this, I need to come here and create a folder. My main program now is adder 8. This is my main program, will be adder 8. This is the full adder that you have just written. This is my adder 8. And here we start Quartz. New project. The project is Adder 8. And the file, the project name is the subfolder Adder 8, and the project will be Adder 8. I need to add this file to it, full adder, but this is not my main file. I can add it later, I can add it now. Add it. Now I am ready to start a new VHDL file. The file name yes, it is Adder 8. Now you go over here and you need to copy this program, page 45 and 46 and 47, 45 to 47. Those 3 slides will be my Adder 8. Doing that, you need to compile full adder. One more time here, under this project, you need to compile Adder 8. After you are done with that, now you go to the waveform. Any questions? Hello, Eric.
Hello, sir.
Is it clear enough?
I think so. Yeah, so far so good.
Okay. Please go ahead, and we'll take at least half an hour for this one. And anyone may share the screen.
Hey, Dr. Mutwally.
Has anybody finished it?
I'm fixing a mistake I made, but I'm close.
I'm done.
It's fine. It don't make sense to me. See how it's not doing anything. Is that same for you? I gotta brush up on adder eights. I don't even understand how they work.
It would make more sense if you hit the arrow on the left side of the screen and drop them, make them expand them.
Like
To
this
the
one.
further left. The arrow on the S. Yeah, there you go.
Okay.
See? Yeah, expand them. It makes more sense that way.
Oh yeah, okay. But why isn't C out ever going up?
So S has to go all the way up to all ones, and then once it goes back down to 0, then the carry out goes high.
Oh, so I never make it to the full count.
Like,
Yeah, you gotta drop your timing to like 5 or 10 nanoseconds every time it counts up on A and B. That's the only
Oh.
way. What I did was I actually started my B on 11000000. That way it starts, B starts at a high number, but A starts at a low number, but it'll add up to carry over.
Okay, makes sense. Thanks.
Yeah, otherwise there's not enough time for it to count that high.
Gotcha. Appreciate it.
you can see when S is all ones, and then right when it goes all zeros, that's when it carries that final one out.
How did you start it as a high number?
I started mine all like, let me zoom out. So if you do, oh, it's not zooming out on funny. When I'm sharing it, it won't let me zoom out. So I did like 100 microseconds. So I just tried to let it kind of do a whole bunch of stuff and then just zoomed in to like take a snapshot.
Nice.
Let's
Isn't there,
zoom
wasn't
out
there a
so
way
we
to
can
manually
see
set
one.
it?
Let's
forgot
see
how
one
you-
cycle.
What'd you say, Professor?
We need to see just one cycle, one addition.
Yeah. Well, I had a screenshot of it, but I zoomed in when I first had it. I zoomed in, but here we go.
If you use the magnifying glass, you can drag and drop over a section and zoom into it.
Yeah, for some reason the hotkeys don't work when I'm sharing.
Let's concentrate on the first part. You are inputting A.
Yep. So it's just counting in binary. Like the sum is counting in binary.
Would you please verify it? I need to verify it.
Yeah,
One,
let me
one.
oh yeah.
Here, the first one. We have here A as 00110100. I am adding to it 00011010 with no carry, So the first one, 0 added to 0, it is 0. The second 0 to 0 is 0. The third is 1 plus 0 is 1. Number 4, 1 and 1 should be 0. And I have a carry of 1. I believe it is working right. And if I compare that to the, oh, don't move it.
Oh, sorry.
If I compare that, the same two numbers, now we have a carry. If I have a carry, 0 is carry in 0, 0, and the carry in of 1, I have here 1. 0, 0, and the carry didn't propagate, so I will have a 0. I believe it is working fine. May I see your program?
Yeah. Can you see the program or?
No.
Okay.
Now I can see it. Yes, go down. Excellent. We need just comment statements.
Okay.
Does anyone need any help on this? Are you still working on it? Is there anyone who finished?
I'm just checking over the answer, but I have what looks to be finished, if you want to see it.
Okay, Daniel, you have shown your program. I'm not gonna give any new material, but I am gonna give an assignment for everybody for next time. I'll share the screen. If you go to YouTube, where you download these lectures, you are gonna see here a YouTube called Test Bench. This one. Test Bench, it is like a waveform generator, but a little bit more sophisticated than the waveform generator. I made this video clip for you, so you can write on your own pace and you can pause and build this circuit for a NOT circuit. So you may do that for next time. This afternoon, I'm gonna continue with whoever needs help on this program, and anybody who finished, you are welcome to leave, no problem at all. And you can work on this video whenever you have time. You can do it now. You are welcome.
I had a quick question.
Yes.
So the homework that's due tonight,
you are ready with it?
Yeah, you want like screenshots of the code and the waveform?
Yes, yes, that's it.
Okay. Perfect, thank you.
We finished all of it.
Yeah.
This is the only part that was missing.
Yeah.
Other 8, you did it. Clear to everybody?
Just a reminder not to forget to do the 4-bit wide inverter and gate before you turn in, since it's ones we didn't do.
The 8-bit, yes, this is the last part. Let me share the screen and we see the assignment together. Homework 1. As you can see, we did everything. The last part, it is the other 8. And I need screenshots of the VHDL code and the waveforms.
Hey, Professor, I got a question.
Yes, sir.
I was just looking ahead at the assignments, and I see that we have a quiz on, is it Tuesday, the 24th? That's our next class.
Okay.
Do we need anything for that? Do we need any particular software or anything for that quiz?
No, nothing.
Okay, just want to make sure.
No problem.
Hey, Professor. I've got, I think the program working, but I'm not sure if I have the waveform correct. Can you take a peek?
Would you show it, please?
I'm sorry?
We trace a step by step. Here, everything is input. The first one, A is 0, 0, and B is 0, 0. And with no carry in, you get everything is 0.
Yep.
Now, the same thing with carry in of 1. So I will get 1. Excellent. Now I go to the third stage. Now you have 1 and all zeros, and the carry is 0. What will you get? You'll get another 1. Excellent. Go to stage 4. Now I have here 1, 1, 1. So I get 1, 1. The rest will be 0. 0, 1. Yes. It's working.
Okay. I wasn't sure if I had the waveform correct. For
No,
the
no,
CN.
you trace it as I did.
Okay.
Step by step. Add them. If it is working, okay, that's it. May I
Okay,
see
so
your
as long as they
program?
add up, we're all good to go.
Yes. If they
Okay.
add wrong, we need to figure out what did we miss?
When we take an image of the waveform, would you like it zoomed in like this so we can actually see the numbers?
No, yes, I need to see the numbers. I need to add as I did. I need to be able to read and add.
Okay, then I'll make sure it's zoomed in where you can see the numbers.
Yes, that's good enough for me. Of course, I'm
All
not
right.
gonna go the whole thing. I'm gonna just grab 2 or 3 points, and that's it.
Okay, perfect. Thank you then.
Could I see the program?
Of course, let me get the screen swapped. Okay, I think you're seeing my code now.
Yep.
Okay. So you've got the entity and where we call the component.
Yep.
I didn't start the project with it. I just copied over the VHDL, but it seems to be
That is
working
what you
fine.
should do. That's what you should do. Copy and paste.
Okay, and then we have a signal C so that we can have a read and write,
Excellent.
and I have 8 in total of these full adders ported out.
This component business, we are gonna use it a lot. That's why I am insisting on seeing your program running, because you are gonna use it over and over.
Okay.
Thank you, sir. You may work on the test bench or you may leave, whatever you like.
Sure, you wanted us to do the test bench by Tuesday before we come to class?
Before coming to class, yes.
Okay. All right, thank you very much.
Thank you. Hello, Eric.
Hello there.
How is it going?
Good. Oh, good. I didn't realize everybody else left. I'm just working through the your video on the test bench.
Okay,
So I'll go ahead and get going and continue working on that.
but you are done with the full adder.
Yes, I am.
Okay, very good.
Well, thank you. You have a good rest of your day.
Do you need any help with this video?
Not so far. I've gotten the test bench running, simulated, and now I'm just trying to zoom into to the waveform. So yeah, I'm working through it.
Okay, I'll be waiting until you tell me you are
Okay.
done. Okay.
Perfect. Okay, it looks like I was able to follow along and get it completed. So now I can view my simulated waveform. Yeah, it looks like I was able to.
Excellent, I can see
Yeah, I
it.
was able to follow along and get it completed.
Yep, working fine.
With that said, I should, in your video, let me go back, let's see. So I will need to create the test bench in that separate file, that VHT file.
Yes,
And that is where I will always make my simulations, my signal simulations, or can I also declare those simulations in my primary VHD file?
what you need to do is, as you can see, Cortex can generate the template for VHT. So it is making the link with your main program and copying everything from there. So all what you need to do is to put the input signal high and low. That's it, as you did.
Okay. So
And of course, you need to insert the weight statement.
Correct. Yeah. Because I was trying this the other day, and yeah, your video really helps me, be able to understand this clearer. But so okay, so if I using this file that it created, the VHT,
yes,
I can copy and paste. But once I become more comfortable building that on my own, I don't need to generate that other file every time.
No, you need because
Okay.
each program will have its own unique input and output.
Okay, cool. I'll try it on this. I'm going to build another program and see if I can get it running. And I'll go from there.
I suggest you have built at the very beginning, this afternoon, you built full adder by itself. It was in a folder by itself, correct?
Correct.
Use it.
Okay, no, for sure, I'll use that and, yeah.
It
simulate
has
that.
A, B, and C in.
Okay, cool, yeah, I'll go with that and, see if I can get it simulated.
Okay. Thank you,
Perfect.
Eric.
Thank you, you have a good rest of your weekend.
You too. Bye-bye.
All right, bye.